There's only one more video from this chapter, right? And it is page 5, okay? So we're on page 5 here. And we're doing examples 6 and 7 from the packet, which use a totally different equation at the very end of the notes for confidence intervals on proportions. So this says, based on a survey at a local college, 46% of the students claim to use the campus library. How many randomly selected students, here we go. This is the question. And they're really asking me, what is n? And we only know one equation from our notes to find n. Let me just record that. It looks something like this craziness. It's the critical value squared times the proportion from the sample who say yes times the proportion who say no, all divided by the margin of error squared. So let's keep reading to make sure we have all the information that we need. It says, how many students must we contact in order to estimate the proportion who use the library to within 2% at the 95% confidence level? So whenever somebody says within, they're telling me that my margin of error is this value, 2% or 0.02. And this 95% confidence level is telling me go look at my chart and figure out what the z-star value at 95% is. And our chart from the notes says 1.96. So we actually have everything we need if we want to convert P and Q into decimals here. In the original problem, it says that 46% of the sample said they'd use the library, which means that the proportion who don't would be 1 minus 0.46 or 0.54. And then I'm going to go ahead and to use this equation. So let's go over here. N equals 1.96 squared times, and then we're going to fill the whole thing in, 0.46 times 0.54, all divided by 0.02 squared. Don't forget to square the margin of error. It makes a drastic difference. The answer here is 2,384 or 85, 0.6, but we need to convert that into the next largest number, whole number. So that's 2,386 students that we would need to survey. That's our final answer. Let's try it again with a different scenario where we just don't have as much information, so we have to make a few guesses. All right, same equation, different ideas in terms of what's given. It says, in preparing a report on the economy, we need to estimate the percent of businesses that plan to hire additional employees in the next 60 days. So this is the same language. How many, can you hear my dog like purring? How many randomly selected businesses, so what is N, that's what they're asking, must we contact in order to create an estimate in which we are 90% confident with a margin of error of 5%. So they're telling me my margin of error is 0.05. They're telling me I want to be 98% confident, which if you recall gave us a z-star critical value of 2.326. But I have no p hat or q hat. So if you remember, we have to guess. If we don't know what p hat and q hat are, we must assume a 50-50 probability here. We say yes and no 50% of the time. So using that information, I'm going to go to my equation. 2.326, we're going to square it. P hat is 0.5, Q hat is 0.5, and I'm going to divide by the margin of error, which is 0.05 squared. Then we can go ahead, and this is 541.03, which we must always round up. So that's 542 businesses. Make sure you round this guy up. And then I'm going to set this one up and I'll let you calculate it and go ahead and check the answer in my video. So this just says, or in my packet, this just says, suppose we want to reduce the margin of error to 3%. So they're still asking me n equals, what is the sample size? So same question, same problem, we're just going to change the margin of error. So I'm going to go ahead and set this up using the exact same equation, and it's really just practice of using the equation and for you to see what happens. Because in this scenario, the margin of error is going to get, the sample size is going to get much larger just from wanting to decrease the margin of error by 2%. Okay, go ahead and find the answer and check with my solutions online. Thanks for watching my videos.